Okay, good morning, students. So this is a class of geotechnical engineering. So we'll start today a new new module or new chapter, that is permeability of soil. Fine, and specifically we are going to discuss about Darcy's law. I hope about Darcy's law it is familiar to you. I think you have got in hydraulics. Okay, so yeah, this is all about passage of water through soil. Fine. So first of all, I'll just share my screen. My screen is visible, right? You can respond in chat box. Okay. So I think you can see this particular notes. So here you can see the name of the topic is what? We're going to discuss about permeability of soil and specifically Darcy's law. Fine. So let me first give an introduction to permeability of soil. Okay, before going in the discussion. So in general, what is permeability? It is a simple, it's a property of soil. Okay, in a very simple definition, permeability is defined or it is as a property of soil. Fine, it's a very simple definition. It's a property of soil. But what is that? What is the significance of this property? This property allow the passage of water or any type of fluids through interconnecting voids of a soil mass. Okay, that means if I join both this sentence, permeability is a property of soil. Permeability is a property of a porous soil or simply a soil by virtue of which which allows the passage of water or flow of water or any type of fluid through interconnecting voids of a soil mass. Fine. Okay. I think permeable soil, permeable matter, impermeable matter. This is, I think, it is already clear to you. What is the difference between permeable substance and impermeable substance? In case of permeable substance, water or any type of fluid can passes through a particular substance because the the voids will be there in a particular substance. Okay. In case of impermeable substance or impermeable object, water cannot passes through the particular object. Like glass. Glass is a simple example of impermeable object. Through glass, water cannot pass through because there is no voids, space, okay, for passage of water. Okay. Now, if you uh, can give me an example of the permeable matter. Okay, like soil itself. Soil is a permeable object, okay, or a permeable thing. Okay. So since soil have voids and through the voids, water can pass through it or any other fluid you can consider. So we can consider soil is a permeable matter. Okay. So this permeability is come from this permeable. Okay. So what is a permeability? It's a property of soil by virtue of which it allows passage of water or any type of fluids through its interconnecting voids in a soil mass. Okay. Fine. Now first, let's come to here. Now, how water can flow? A water is flowed due to gravity. It is already known to you, right? Now, there is a term called hydraulic gradient. I think this is also familiar to you. But anyway, I just want to explain here what is hydraulic gradient. Fine. Let me take one pen here. Yeah. So suppose this is a hill. Okay, this is a hill area. Hill. Okay. Now suppose as usual you know water is flowing water will flow in this direction, isn't it? But if you say technically, what is the mechanism or what is that science behind this? You all know the water is flow under gravity, of course. Okay, but also there is a hydraulic gradient because of which water flow from, say, this is point A, this is point A, this is point B. Okay, now what is hydraulic gradient? Hydraulic gradient is represented by small I. It is symbol small I divided by hydraulic head by length traveled by the water. Okay, so H by L, it's a ratio of H by L. Now in this case, what is H and what is L? Let me tell you. So this vertical distance between A, let me give a horizontal line. Okay, now the vertical distance between A and B, the vertical distance between A and B, it is what? It is your H, or sometimes it is also known as delta H. Okay, it is H, the vertical distance between the point, and the horizontal distance between A and B, it is given, or it is denoted by L. Okay, I think it is clear to you. So due to this hydraulic gradient, it is denoted by small I, which is a ratio of hydraulic head, or sometimes it is also given as a delta H. Wait. Sometimes also denoted as delta H. Okay, that is a head difference, the head difference between these 2 points. And this is the length traveled by the water, the horizontal distance traveled by the water. Okay, so this is denoted by L. So this is also occurs in case of, this is also accepted in case of soil also. Okay, so in general there are total three heads or three components of heads are exist for the flow of water. Okay, one is your elevation head, that is the elevation head, the what is the, or the difference of head between point 1 to point B, like that. Pressure head and velocity head, these three component of the head comprises of total head. Because of this total head, water flow from one point to another. Fine. Now in case of soil, the velocity head is too small. Okay, since the velocity is very negligible, you can see the velocity or seepage velocity in soil is normally very low. That's why this velocity head is ignored. So in general, for soil, only in case of soil, or if we talk about the flow water through soil, we only consider about elevation head and pressure head. Fine, we'll ignore the velocity head. Okay. Now, since we are discussing about permeability, okay, now in this concept, Darcy have given his unique explanation of permeability or flow water. Fine. So as per Darcy, what is the Darcy's law? I'm going to explain now. Now, as per Darcy's law, the rate of discharge. The rate of discharge means, here you can see the rate of discharge means what? The water flowing per unit time. In it given in the unit of meter cube per second. Okay? That's why value volume per time. So rate of discharge or rate of flow or unit discharge through a soil. If you consider this diagram, okay, let's discuss this diagram. Suppose this is a three-dimensional soil element, okay, having a length of L in this direction, I think you can see here, and cross-sectional area on this side is denoted by capital A, and here you can see two piezometer is inserted at this point, at this end. Okay, now since you can see the head is higher at point A compared to point B, that means water will flow in this direction. Fine. So as per hydraulic gradient, since there is existence of hydraulic gradient, so water will flow in that direction. Let me take one pen again. So water will flow in this direction. Okay, in this direction. Okay, so since water is flowing in this direction, let me take one pen again. Yeah, so since water is flowing in this direction, okay, so as per Darcy's law, okay, here listen carefully. So Darcy's law state that the rate of discharge denoted by small q, the rate of discharge means the water flowing per unit time. The rate of discharge flowing through a particular soil element is proportional is proportional to the cross-sectional area is proportional to the cross-sectional area perpendicular to the flow, and it is also proportional to the hydraulic gradient. Okay, so if I go mathematically, the representation of Darcy's law, the rate of discharge is proportional to the cross-sectional area this area perpendicular to the flow, because you can see in a particular soil element there are numbers of cross-sectional area you can see, but which cross-sectional area we have to consider, which is perpendicular to the flow. Since the flow is going through in this direction, so the area which is perpendicular to this particular flow is this one, this area, isn't it? So this area, isn't it? So we have to consider particular this area. Okay, so also Darcy's also state that this rate of discharge is also proportional to the hydraulic gradient. Now hydraulic gradient, you know, you can also represent by h by sorry h by L. Here in this diagram the h is represented by delta h, so let's just give delta h. Same thing. Okay, okay, someone is waiting. Fine. So as per Darcy's law, rate of discharge is proportional to the cross-sectional area perpendicular to the flow. Also, it is proportional to the hydraulic gradient. Okay. So we can combine both all these two test statement, and we can rewrite that Q is proportional to I into A. Okay, we have combined both statement. So mathematically, if we replace the proportional symbol with a equal symbol, one constant term will come. Let's say the constant is k, and I A. It's very simple mathematics. So rate of discharge is equal to KIA. Now in this case, this k is what? It is this k is known as coefficient of permeability. Okay, here you can see k is what? K is your coefficient permeability of soil, or coefficient of permeability. Fine. So if you write, you can also find out the discharge or flow velocity V. You can also find out, as in general, you know the definition of V or the definition of discharge. Rate of discharge is defined as a multiplication of velocity multiplied by cross-sectional area, V into A. So we can write velocity equal to Q by A, isn't it? Now what is Q? Q is equal to KIA. Now KIA divided by A, you will get KI simply. So we can write V is equal to KI. Okay? This is your discharge velocity or theoretical velocity. Okay? So theoretical velocity or discharge velocity of flow of water through soil, V is given as KI, where K is your coefficient of permeability, I is your hydraulic gradient, and this is your Darcy's law. Okay? You can also go through this, reading these notes, you will get it. Okay? So at the end, I want to give one last thing I want to share with you. the difference between uh, discharge velocity and seepage velocity. Okay, so there are two kind of velocity we can study in case of flow water through soil. One is a discharge velocity, or sometimes known as is Darcian velocity or superficial velocity. Huh. And another one is your seepage velocity or true velocity or actual velocity. Okay. So what is the basic difference between these two? Now, when you say that discharge velocity or Darcian velocity or superficial velocity, we consider the cross-sectional area which is perpendicular to the direction of the flow. We consider the whole cross-sectional area perpendicular to the direction of the flow, since water flow in this direction. From the arrow mark also you can see. But when you say the seepage velocity or true velocity or actual velocity, in that case, we are not going to consider the whole capital A or whole cross-sectional area perpendicular to the direction of the flow. We only consider the cross-sectional area of the voids present along this direction. Since actually the water flowing through the voids only, not through the whole area. Since when you say the total or capital A in this case, so this capital A, the cross-sectional area, it considered both, that is the cross-sectional area of water and cross-sectional area of the soil solid also. But as you know, actually this water flow through the voids part only, not through the soil solid part. So that's why when you want to define seepage velocity, okay, or actual or true velocity, we have to consider only the volume or only the area of the voids only. Okay, only area of the voids, not total area of the cross section. Okay, so this is a difference. So mathematically, you can say the seepage velocity is always higher than your Darcian velocity or discharge velocity. Okay, here also you can go through this statement. It is very simple to understand. Okay, so there is also a relation between seepage velocity and discharge velocity. Now you can see Vs, that is denoted by which is denotation of seepage velocity. Okay, the seepage velocity is denoted by Vs. So mathematically, or there is a relation between seepage velocity and discharge velocity, and it is related by this equation V by N, that is discharge velocity divided by porosity, where N is your porosity. Okay, so in some problem, if you got some problem in a mathematical problem, suppose you are asked to find out seepage velocity, but you are given as a discharge velocity, then simply if you are also given by the porosity of the soil, just divide the discharge velocity by porosity, you will get the value of seepage velocity. Okay, so it is clear to you. So this is all about today class. So it is the introduction class or basic class of permeability of soil. So we have discussed about Darcy's law specifically. Okay. So with this, I just want to conclude my class here. I just want to close my sharing now. Is there any doubt till now? Okay, hold on a second. Okay. ओके, डाउट नहीं है किसी का? ठीक है, अगर नहीं है तो इट्स ओके, आई जस्ट टेक द अटेंडेंस नाउ। ओके, वेट अ सेकंड। Okay, respond to your call. Three, November. Okay, roll number 1,
Yes, sir.
roll number 2,
Yes, sir.
3,
Present, sir.
4,
Present, sir.
5, 6, 7, 8,
Yes, sir.
9. Okay, 8 है ना? 9,
Present, sir.
10, 11, 12, 13.
Present, sir.
Okay, 12, ठीक है। 13,
Yes, sir.
14,
Present, sir.
15, 16, 17,
Present, sir.
7 दिया हुआ है, 18, 19,
Yes, sir.
19.
Yes, sir.
Okay,
Yes, sir.
20, 21,
Yes, sir.
22,
Yes, sir.
23,
Yes, sir.
24,
Yes, sir.
25,
Present, sir.
26,
Present, sir.
27, 28, 17, 17 दिया हुआ है, 28, 29,
Yes, sir.
30, 29,
Present, sir.
29 है क्या? 29?
Yes, sir.
ओके, 30 भी है ना?
Present, sir.
31, 32, 32. ओके,
Present, sir. Present,
ठीक
sir.
है, ठीक है, ठीक है। 33, 20 given,
Yes.
33, 34, ठीक है,
Yes, sir.
35, 36, 37, 38, 39, 40, 40 है, 40, 40, 41 है,
Present, sir.
42, 43, 44, 45,
Yes, sir.
45, ठीक है,
Present, yes, sir.
46,
Yes, sir.
47,
Yes, sir.
48, 49, 50, 50. Anyone left to give attendance?